The last thing we need to talk about with congruent triangles is when the instructions are to find the missing side or angle that would make two triangles congruent by specific theorems. The first thing that we need to do is identify any understood congruent angles or sides. This is things like vertical angles or shared sides that we can use the reflexive property for. So we have some normal diagrams we've been looking at. So the first one, I have vertical angles. Second one, I have a shared side I could use reflexive property on. And last one is another shared side I could use reflexive property for. So we want to identify those first. We don't need to state those as the needed information because we already have it. Then we ask, what do we want? And then what type of info, side or angle, is missing? So let's look at some examples. In the first example, we're given two sides. So if I want to do side, 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 I need another side. So if you want to put, we need an S there. And this one is pretty straightforward. We just need AC to be congruent to DF. If I want side angle side, I have two sides, so what I'm missing is an angle. And specifically, it needs to be the angle between the two sides I'm already given. So that would be that angle B is congruent to angle E. If we go to the right, the first thing I'm looking for is angle side angle. What I have is a side and an angle. So I need the angle that's on the other side of my side. So that would be angle A needs to be congruent to angle D. What you want to be careful of is not to start marking up your triangle while I'm deciding what it is I need. If you do, mark it, erase it before the next part of the problem so you don't start thinking that was the information you were given. For instance, for this I might mark A and D, but then before I go to the next step, I'm going to go in and erase that so I don't get confused. So the next one is angle side, so I want the angle that's not attached to the side that I have. So that would be angle B needs to be congruent to angle E. For side angle side, I need the other side, and it needs to be the one that is going to make the angle included. So that would be CB needs to be congruent to FE. The next ones, we have something where we can be adding information. So I have a bow tie figure here, so I can add a pair of vertical angles. I don't need to write that down. We're not doing a formal proof. And now I'm saying, in addition to that, what do I need to say that these are angle, side, angle? And I just realized we have a boo-boo on your paper. So there is BD is marked on your paper, but it really needs to be BE. So if you could fix that, that's just a typo. So back to the regularly scheduled program, ASA means that I need to have the angle on the other side of the side I was given. So in the top one, that would be angle A needs to be congruent to angle E. If instead of ASA, I want an AAS, that means I want the angle that's not touching that given side. So that would be angle D congruent to angle F. And side angle side means I need that vertical angle to be what's included. So that would be side DB congruent to side FB. And the last one, notice we have a shared side, so I can add that congruence marking using the reflexive property. And the first thing it wants is side, side, side. So obviously if I have side, 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 I need the third side. So I'm going to do BA needs to be congruent to CD. And the last one where I put this particular side angle side is because I can't just name it with one letter because my vertex has multiple angles coming off of it. So I need to make sure for these ones I'm using 3 letters. So I'm going to write it as ACB is congruent to DBC.